Hi everyone, welcome to BuildKite's first conference, UnblockConf21. I'm Oliver from Pinterest. I'm super excited to be here and speak to you about our story moving Pinterest iOS builds cluster to the newest AWS EC2 Mac instances and how we create Mac autoscaling clusters. For today's presentation, we're going to walk through Pinterest migration journey to show you what the before and the after. And we're also going to walk through our new iOS CI architecture to show you how Packer, Terraform, EC2 Mac, and autoscaling all work together. And then we're going to show you how to do AMI creations using Packer and Bazel. Then we're going to show you how to set up an AWS autoscaling group with your EC2 Mac. Then finally, we'll have some Q&A and next steps. At the end of the presentation, I would like you to learn 1. The benefit of migrating build clusters to AWS. 2. How to create Amazon Machine Images, or AMI, for your EC2 Mac instances to fit your iOS build needs using Packer and Bazel. 3. How to create EC2 Mac autoscaling group using Terraform. Okay, let's get started. First, a quick intro about Pinterest. For those who are not familiar with Pinterest, Pinterest is a social media app. Our mission is to bring everyone the inspiration to create a life they love. We have 450 million plus global monthly active users, 300 billion pins saved, and more than 2,500 employees. So at Pinterest, we're supporting a lot of engineers and a lot of builds every day. What we had before EC2 Mac instances are on-premise Mac Pro systems that need to be physically procured. Configuring and upgrading these machines was not easy due to their physical nature, and they usually require frequent reboot due to prolonged uptime, which can cause service disruptions. And above all, the most limiting factor to our build throughput is that our build resources is limited. We cannot just go spin up more machines in the middle of the day. What we have now with EC2 Mac instances is that we can autoscale to meet our build demands using BuildKite Agent Scaler Lambda function. It's a Lambda function that BuildKite provided, and it's awesome. I love it. I will share a link at the end of the presentation. And we can also now upgrade our build machines more reliably and faster with AMI. We have version build cluster with AWS launch templates, and we can easily customize access privileges per cluster with AWS Identity and Access Management, also known as AWS IAM. Besides AWS services I've mentioned, there are other AWS services we take advantage of since transition to EC2 Mac, like AWS Secret Managers to help us rotate, manage, and retrieve database credentials, API keys, and other secrets throughout their lifecycle. We use CloudWatch for centralized BuildKite Agent Metrics, which relies on BuildKite Agent Metric Lambda provided by BuildKite. I will also share this link at the end of the presentation. We use EBS to dynamically adjust our instance and storage per cluster, and RDS to easily create databases and backup to store build metrics. What made us successful is not just transitioning to EC2 Mac and utilizing the AWS ecosystem, but also a new CI architecture. You can see that now our BuildKite pipelines are built by specific queue depending on the pipeline's nature. Like our iOS release pipelines built by iOS release queue, and our iOS integration test pipelines built by our iOS test queue. Each of these queues are attached with their own autoscaling group, and the autoscaling group will adjust the queue size depending on the build demands. The autoscaling group is also paired with their own launch templates. In launch templates, you can specify versions. In a version of a launch template, you can specify things like VPC and subnet where you want to launch your clusters into. You can also specify which AMI to use in that version. So by specifying the version to use in the autoscaling process, you can effectively manage the version of your build clusters. All the AMI and AMI registry are created through our AMI creation pipeline, which uses Packer and Bazel. We'll cover that more later in the presentations. You will also notice that in our AWS IAM, there are different policy and roles. Depending on what the clusters need, we'll attach different policies to a role and give that role as instance profile to all the instances in the build cluster. For example, our iOS release queue have a role that have a policy attached to allow them access release-related secret and AWS Secret Manager to allow them to push the app to the App Store. But other queues such as iOS Test and iOS does not have a role with that policy attached, so they cannot access that release secrets. Finally, all these AWS resources are managed by Terraform, which we'll cover later in the presentations. We use an account modules to create all the roles and policies, and the queue module to create all the queues. In the end, we're very pleased by the positive impact of the migration. Comparing pipelines now run by EC2 Mac autoscale clusters that used to run by on-premise machine, we see a 18.4% of speed improvements, 80.5% less CI-related build failures. So they're much more reliable, and a 43% reduction in upgrade times. So it's much easier to install new libraries or upgrade to a new version of Xcode. I know what you're thinking. How can I do the same? This is awesome. Well, let's start by learning how to create AMI to power your EC2 Mac instances to fit your organization's build needs. EC2 Mac AMI can be broken down into two layers. There's the base layer, which include Amazon EC2 Mac OS AMI, so things like Mac OS Big Sur 11.5.1 and Xcode. The reason why we include Xcode in the base layer is because that Xcode installation process are usually very lengthy, and if we just want to do a small tooling upgrade and install a new library in our AMI, we don't want to rerun the whole process just to reinstall Xcode again. Sitting on top of the base AMI, there is a customized layer. This is where you will install your tools, your library, configure your secret, install build kite agents, and together these two layers is what makes your machine image. We're going to use Packer to create our AMI. Packer create identical machine images for multiple platforms from a single source configuration. Usually this configuration is in a config.json file. How Packer works is that it will take a source AMI, so a source image, and use that to spin up a machine in AWS, and then it will run a bunch of provisioners on that machine, such as like a script that installs Xcode. And when it's done with all the provisioners, it will take a snapshot of that instances and turn that into a new image, which is your newest AMI. And you can see in this config.json, I've named that, hey, the resolved AMI, I want to name it buildkite-bigser-build number, which is extracted from, it's a variable extracting the buildkite build number environmental variable and dash timestamp. In your config.json, you can also specify, hey, the instance type you want Packer to spin up the instance with, and the tenancy you want to use, and like which availability zone you want to spin up your machine in. If you want to get fancy, you can use Bazel to pull in Packer. There's a deploy Packer rule from Vatical Bazel Distribution GitHub repository. In your workspace file, specify the commit and the remote to load that GitHub repository, and then load the deps.bzl file, which include the Packer binary. And then in your build file, specify package target, which package up all your relevant file, including the config.json, and then load the rule.bazel from the GitHub repository to use the deploy Packer rule. This rule will automatically run Packer for you using the binary extracted from the GitHub repository, and it will automatically register the AMI for you in your AWS account. Finally, to run that, use a Bazel run and the target of your deploy. Remember, you have to specify these two AWS environmental variables due to the Mac1.metal instance's lengthy scrubbing process. You want to avoid Packer timeout. So I put that one single command into a deploy.sh file. And then on my build kite pipeline, I simply run that shell script. So you can see that here is build number 7. It runs. It creates this AMI 0b5e ... And then if I go to my AWS account, see my AWS registry, I can see this AMI, and then voila, the name here is the build, references back to the build number, because I told it to use that variable defined by the build kite build number environmental variable. Being able to reference back to which build pipeline created AMI is quite useful, because you can see which AMI is created by which commit, and knowing that what is being installed exactly on the AMI. And you can also see if there was a creation error on your AMI by going back to see the build kite logs. Now you know how to create AMI, you want to know what things you want to include in your AMIs for your iOS build. iOS CI job often need to run UI tests in the iOS simulator. To do this, Mac need to be logged in as user, and the build agent needs to be started as part of that user session. We can achieve this by running iOS build agent as launch agent with user session property set to true in the plist. By using launch agents, builds will be able to perform UI interactions, making it possible to run tests in the iOS simulator. Another frequent component of iOS CI job are running codesign and accessing your keychain where you store your certificates. Codesign is a pretty sensitive bit of Mac OS and require elevated privileges to access the keychain. Running build agent as launch agent with a user session will give your build agent permission to access keychains so you can run codesign as part of your build. Since launch agent will be running only when the user is logged in, you should enable auto logging on your Mac OS machine. So every time when your EC2 Mac is up and running, the build agent will automatically be launched. It is worth noting Mac OS also has Launch Daemon. It's a service running completely in the background. Launch Daemon run on system startup, but they don't have the same access to the UI interaction as launch agent, meaning your build won't be able to run and UI tests. You will also likely run into error security internal component when you try to access your keychain. There's one more important thing you absolutely need your AMI. But first, I want to tell you a funny story. When we just started building our UI test on EC2 Macs, we started running to flaky UI test. We see that flakiness of our UI test increases throughout the day, and then tomorrow morning when the build clusters scale down and scale up again, the UI flakiness will go away but increase throughout the day. And this is driving us crazy. We don't know what caused this. And turns out it was caused by the screen went to sleep. So you want to configure EC2 Mac instances to never sleep. I think this one line of code in your AMI should take care of it. Okay, now you know how to create AMI, what to put in your AMI. You want to know how to set up an AWS autoscaling group with your EC2 Mac instances using Terraform. We use Terraform at Pinterest to manage all AWS resources for our iOS build infrastructure. For those who doesn't know Terraform, it is an infrastructure as code software tool that provides a consistent CLI workflow to manage cloud services, including AWS. I know what some of you are thinking. Why use Terraform? It is so much easier to do things via the AWS console. Well, there are a few reasons. Infrastructure as code. You can make code review a necessity of your infrastructure change. Version software. You can check out the older commit, reapply that, and voila, you can restore the older version of your infrastructure. If somebody accidentally deleted your AWS account, no problem, just reapply the code using Terraform. Then you can restore your AWS account. Finally, consistency. By reapplying the same code, you always get the same sets of AWS resources created every time, which is great. Okay, now we know how to use Terraform. Let's see if we can use it to create an EC2 Mac autoscaling group. This is a zoom-in view from earlier CI architecture diagram. There are 4 AWS resources we're going to create today using Terraform. We're going to create a license configuration, a dedicated host group, a launch template, and an autoscaling group. Unlike other EC2 instances, EC2 Mac instances need to run a dedicated host. So to create EC2 Mac autoscaling group, we first need to create a dedicated host group, where dedicated hosts can be launched. But dedicated host group require license configuration, so we first need to create a license configuration which can use to configure your eligible software license from vendors such as Microsoft, SAP, etc. onto your dedicated host. Then we're going to use the license to create a dedicated host group. In case of EC2 Mac, these dedicated hosts are Mac Minis. Then we're going to create a launch template and associate a dedicated host group with this launch template. Finally, we're going to create the autoscaling group. The autoscaling group will use the launch template we created earlier. And then, depending on the version of the launch template, launching different versions of instances into your build clusters that will be used to build builds on your build pipeline. Okay, step 1, create a license configuration. In Terraform, there are resources. Resources are the most important element in Terraform language. Each resource block describes one or more infrastructure object, such as virtual network, compute instances, or higher-level components such as DNS records. You can think of a Terraform resource block mapped to an AWS resource. In this example, we're creating an AWS license manager license configuration. That's the resource type. And we're calling this resource name demo license. But the resource that's going to be created in AWS instances have a name called demo iOS build. And then for the purpose of this presentation, I'm creating a core license that I can use to choose to enforce limit on number of core of my dedicated host group that can launch. Step 2, create a dedicated host group. Now we have a license configuration, we can continue to set up dedicated host group that can launch new dedicated hosts if our autoscaling group needs it. Terraform doesn't have dedicated host group resource, so we are going to have to create it via CloudFormation. AWS CloudFormation is a service that helps you model and set up your AWS resources. You can create a template that describes all the AWS resources that you want, and CloudFormation take care of provisioning and configuring these resources for you. Note that the 70 line of Terraform code won't fit here. So there are other configuration parameters like allowed host family. In our cases, we want to specify Mac 1 family for EC2 Mac instances. I'll show you the full code later in the demo. Also, I'll give you a link to the gist at the end of the presentation to the demo code. Now we can finally create a launch template. Here we're creating a launch template. I'm going to call this launch template build kite agent. And the instance type was specified to Mac1.metal. The license configuration was specified to the license that we created earlier. Here you will see AWS license manager, a license configuration.buildkite iOS agent, which we named earlier, .arn. ARN just means Amazon resource number. Every Amazon resource has a number. It's kind of like their ID. And here we'll specify the placement as hosts and using the host resource group ARN that we created earlier. Finally, we create an autoscaling group. We're going to create an autoscaling group here using the launch template we just created, and we always use a version of latest. All right, let's do some demo and show you how this works. All right, so here are all the code that we just went through in the presentation, right? You have the license configuration, you have launch template, autoscaling group, CloudFormation stack for the dedicated resource hosts. There's some local variable defined here. I'll talk about them later, but first, to see what this will create, we simply type Terraform plan. So Terraform plan will basically, it's like a dry run. It will say, hey, if I do apply all these resources, what will create? So here you see like, hey, if we do apply, it's going to create license configuration. It's going to create a launch template, and it's going to create a dedicated host that I talk about. So I'm going to go ahead and do a Terraform apply, let it run. So while this is applying this way, I can show you that in this dedicated host group, I mentioned there's more parameter that you will need, such as like, hey, do you want to allow what kind of host family? You want to allow the Mac 1 family? Do you want to auto allocate hosts? You do, because when the auto scaling group needs more dedicated hosts, you want to auto allocate more, and you want to auto release when it's done with it, right? You can also configure other things like, do you want deletion protection or whatnot? Let me minimize this. And then, so now, let's see. You have to type yes for this to actually apply. Before we apply though, I want to show you, this is the corresponding AWS account I created for the demo purpose. If first we go check an autoscaling group, you can see like there are no autoscaling group, it's just to the welcome page. If we go to launch template, there are no launch template. Also just go to the welcome page. So I'm now going to go back here. We're going to apply yes. And then this will be, while it's applying, I'll tell you a little more about the code. So here you see this local variable cluster name and this data block called AWS AMI. This data block is used in this AWS launch template. You can see here, it says the image ID uses data.awsami.macosami.id. So it's just saying like, hey, use whatever this data block output is. I'll use that as the AMI ID. And this data block is simply just search anything that fits this filter, Amazon EC2 Mac OS 11.4. So it's really probably just grabbing the 11.4 Big Sur AMI, the public one provided by AWS. This local cluster name iOS, it's used here, it's referenced as local.clustername. So it's creating an auto-scaling group named called iOS. Let's check if it's down applying. It is down applying. All right, let's go to AWS. So now if we refresh this page, or let's go to auto-scaling group, there is an auto-scaling group called iOS that's being created. Awesome. If we check out this auto-scaling group, it's associated to a launch template like we told it to. Perfect. Let's look at that launch template. It's probably associated to an AMI. Mac one on metal, yes, AMI ID, copy that. Let's see what the AMI is. Go to the AMI registry, search for it. It is 11.4 Amazon EC2 machine image, one of the big SIRs. Sweet. So what if I don't want to use this AMI anymore? Let's go back to our Terraform code. So instead of using this data block, AWS AMI, what if I want to say use a different AMI? Maybe I want the newest Big Sur. So let's see. If we search Mac OS, so we can find something here. 10.14. Let's use the latest 11.6. 2021, September 24th is the creation day. All right, let me copy this AMI directly. Oops, so my screen is very zoomed in for the demo. I'll copy the AMI, go back, and say using this data block, make that change. I'll have to quote it. Okay, so now if I do a Terraform, I'm gonna do it apply, skipping the planning, for demo purposes, but it will still ask me what do I want to be the change I'm making. So every time I try to create a modified launch template, a new one actually gets created for me. That's why the latest version says it's known after apply. It's probably going to be version 2. You see here I'm swapping out the AMI to a different AMI ID. Let's say yes. Perfect. It's done. Let's go back to the AWS account. Let's see, go to launch template. You see now there's version 1. It's the old AMI, the one we just checked out. But if we go see the version 2, this AMI 03 E6, which is the one we just told it to create. So now say if we're testing this in, I don't know, in stage now, I want it ready to roll out to production. I just simply say, hey, set default version to 2. 1 was default before. Now if I set this to default version to 2, the autoscaling group will start launching this version of images into the cluster. And that's how you use Terraform to create and manage your EC2 autoscaling groups. What's next for us on the agenda? Next stop is to get observability and metrics from Buildkite using Honeycomb. Honeycomb is a great tool to detect anomalies and patterns from large datasets. I've seen other organizations use Honeycomb to effectively analyze pattern in Buildkite logs to detect flaky tests or triage outage. There's a technical webinar tomorrow about build observability with Honeycomb. I'm super excited about that. Go check it out. Now we're in the end. It's time to give some thanks. I cannot have done the project or put the presentation together without my friends from AWS, Buildkite, and Pinterest. Mel and Keith from Buildkite have given me unparalleled amount of support to put the presentation together. I also want to give a big shout out to Garrett from Pinterest for all the guidance they have gave me since I joined to pull the project together. I cannot have done it without him. Finally, I want to give a big thanks to the iOS community. By no means we did any groundbreaking works here today. All the work we presented today are work coming from the community. iOS CI builds have many challenging issues, dealing with security, certificates, Xcode installations, and updates, and the community have been working on solving these issues for years now. What the team and I did here today is just putting the stories and finding from different parts of the internet together. Finally, we're hiring. Come work with us. You can connect with me on LinkedIn, or you can shoot me an email at oq@pinterest.com. Any questions?